We're going to take a look at a specific power series now. So a power series was defined as such.
Why? It's a 6.
Okay.
Yeah.
So you have a sequence times x minus c to the n. Basically what we say is you put an x in a series. Right? Okay. Here is a, now let's expand that out. Right?
Oh my goodness, so much rain.
Is that a to 0?
Yes.
Okay.
A sub-zero.
A sub 0.
Subscript. Okay, now, can this be simplified to a sub 0 plus a sub 1?
Yeah. Indeed it can.
Okay, all right, power series. What do you remember a Taylor polynomial is? Centered at C.
It's the
What's the first term?
just to test.
It's FSC.
Plus?
F minus C times C minus A? Or
X minus C.
no, X minus C
To the end.
over N.
Over
factorial.
First term.
To the first.
Over.
1 factorial.
N factorial.
Okay. Plus?
F double prime C X minus C squared over 2 factorial. These homeworks are already done.
You see a connection.
Yes.
Okay. Can we write that as a series similar to this?
I don't know how you get to factorial though.
It's what it is.
Oh, N factorial?
Okay.
Sorry.
Because it's 0 factorial, 1
Times X
factorial.
minus C
Okay.
to the N.
X minus c to the n.
And then F, and then can you do N of X?
Nth derivative at center.
Huh,
Taylor series.
that's nifty.
Yep.
So it's a general formula, but we just put a series of it.
Yeah, well, Taylor polynomial is a series. You're adding up a string of infinite terms, right? It's an infinite series. You just didn't know that when we were studying polynomials. You didn't know what a series was. Okay. So you will, so we will still generate Taylor polynomials, but the next step is to generate the series notation from that polynomial. Okay, so let's generate, find the Taylor series. For x to the negative third, centered at c equals 1. Okay, ready to go. Write the Taylor polynomial.
Roger.
Seriously.
And then we will backtrack and make this, write the series
Okay.
notation, which is all ball of fun.
So, let's see. That can't be right. Yeah.
Am I doing derivatives? The number keeps getting bigger.
Yeah, it's because it's a negative X on
Yeah,
it.
that's what was confusing me.
Yeah.
Let's see. That's weird. Yeah, that confuses me. Why is my most How many terms do we go out with these?
Enough to write the series.
2.
3 to 4 is usually a pretty good guideline.
Including the first one?
Yeah. So degree 2 to 3, 3 to 4 terms, remember that difference? All right, we will address it then.
Look how accurate it is, right?
Yeah, the more you do, the better you're.
No, like degree was different than terms. Like one was started at index 0, the other one.
Degree was simply the nth value, while terms was how many you did past the
So-
original.
Yeah, degree started at index 0. How? Yeah.
What do you got, Mason? What's your,
Not that, what?
Oh,
You
you're in
did.
trouble, Brian.
Yeah.
You did that?
what is your Taylor polynomial?
Add 1 plus x minus c.
What's C?
Or 1.
1?
And then I moved on to 1/8 x minus 1 squared over 2. I've done something horribly wrong and I can't figure out what I've done.
And we know that this is gonna happen.
When you plug in 1 for x, when you evaluate f count and stuff, you read that as 1 to the negative 4 times 3, not negative 3 to the negative 4.
What are your derivatives?
Negative 3
Okay, so
times
your
one.
derivative,
That's what I-
Negative
okay,
3.
that's
first
what I
derivative,
needed.
that one, negative 3 over 1 factorial, right?
Mhm.
Okay, what's this one?
Completely lost
Yeah,
in what I was
12
doing.
over 2 factorial. Negative 60 over 4 factorial.
3 factorial.
3 factorial, sorry.
Killing it.
I forgot that we derived.
Okay, so this is approximately f of x, correct?
Yes.
Yeah.
It's altered.
Okay, so let's do 1 minus 3 x minus 1 plus 6 minus 10. Okay. Write the series notation. Okay, so you said what, Monty?
It's alternating.
Okay, negative 1 to the n or n plus 1? What if n is 1?
It's negative.
Negative, so
it's
leave
negative
it.
at 1.
Okay, and then we know that we have x minus 1 to the n, right?
Yes.
Mhm.
And divided by n factorial.
How do we generate these terms.
Negative 1, oh wait. You're right, over there.
View.
Yeah.
G6.
Two and minus one? No. Not that at all.
That was a good try.
It's sometimes easier to stay up here.
Over and factorial? So it goes 3, 12, 60. Oh, 3 to the power of n?
Okay, let's try it. 3 to the first is 3, 3 squared is 9. No.
Is it
dang
3
it.
times 2? Or,
3 times 2 is 6.
wait, let me rethink that. 3 times then.
No.
No, it's the first one.
No, 79.
They're right.
I took my elbow down, just fell through the crack.
I brought my feet up, just as he said his elbow.
I'm glad they can have fun.
Dude, I just felt like smack my teeth on the desk. That was really awesome and super
The
unfortunate.
joys of having a class of 6.
It is.
That was scary, not gonna lie. My heart just hit the- Sorry about that. You're good.
Okay.
You're pretty lost.
I'm going to save you the pain and suffering.
What?
What?
Okay, never in a million years would I have derived that myself.
Okay.
You just wanted us to struggle.
Yeah, I did. I like to see the pain and suffering. Yeah, n plus 2, so 1 plus 2 factorial is 3 factorial, right?
Which is 6 times a half is 3.
Divided by 1. So there's your series
Wow.
notation. Now you're not going to have to do that very often,
Okay.
and it's not going to be that difficult. Okay.
That didn't seem that difficult to you.
Okay. Where the rubber really hits the road here is knowing all of the main functions in series notation.
So,
Okay, so do you know, so sin x as a Taylor polynomial, we've done this. This is actually a MacDaddy polynomial. Remember MacDaddy polynomials?
We did the ones that are centered at 1.
Centered at 0. Okay, here's your MacDaddy polynomial for sin x.
Why did he leave the drink here?
Because we're going to write the series for it. Okay, is it alternating?
yeah.
Yes.
Okay, so we know -1 to the n. Okay. In math, how do you generate a negative number? Or an odd number?
Add 1 or 2.
Times it by an even number.
And?
Add 1.
There you go.
Hey.
Teamwork. That's how we get the odd exponents. And how do we get the odd factorials that match?
2n plus 1 times.
There's your series notation for sin x. Okay. You will work with those more than any other series on for your responses.
Sines or Taylor series?
No sine, cosine, e. I'm not that good.
No, that'd be
1 over 1 minus x, 1 over 1 plus x, natural log 1 plus x, tan inverse x.
10 inverse?
7 of them.
Well,
We're going to make cards for it, and I would suggest that you memorize them so you don't have to, like you could create that
takes time.
by a Taylor polynomial, but you're saving a ton of time memorizing these. Okay. So turn to the,
Time is gonna do something we fight for, right?
so write that
On a card?
on a card. So you'll write on your card, Taylor series for sin x. Write these two items. And then we'll do cosine. And E. Yes, screw that up. EVX is the easiest one.
Say A.
Four of those. Count correctly.
So all these are Mac Daddy polynomials?
Yeah.
Or something like that?
Maclaurin polynomials. Sends chills down my spine.
Did I totally bomb that test?
I haven't graded it.
Okay.
You waited a fat minute.
Yeah.
That was,
Not wise.
that was your biggest mistake. Cause I'm pretty sure all this would drop like a letter grade if we were to retake that right now.
Gosh, my arm's getting tired.
I took a look at it.
Very in person.
Today is Wednesday.
Yep.
Yes, sir.
Wow.
Okay.
Alright, this is a multi-part lesson.
It is. Okay. Your job while I'm gone is to make cards for the four other series on page 599. Take at least 7 cards, put them in the cabinet if you need more, and work on this. I will leave some series practice for you for classwork.
Okay, that's where the card.
Capiche?
Fine.
You need more cards? Yes.
Ooh, that's a selfie. I do love my selfie.
Feels like over.
Another one actually.
It's a giant building review.
I know.
Have a nice rest of your day.